And we are back. We are going to do solving systems algebraically because graphing is pretty fun, but sometimes you want to do something that's a little more efficient. And sometimes things are a real hassle to graph or determine where they cross if they don't cross at perfectly whole number points. So we are going to go through and learn how to do substitution and elimination. This is going through kind of the same things. We're talking about substitution and elimination. When you solve a system, the answer is either an ordered pair, which happens most of the time, no solution. So what's going to happen here is you're going to go ahead and you're going to do your work. And in the end, you're going to get something like 2 equals 5, which is not actually a fact. And so you get a false statement. All the variables are gone. There's no x, there's no y. You get a false statement, and that means there's no solution, which still means that if you graphed them, they'd be parallel. The other option is you're going to get the infinitely many solutions. That's going to happen when you're doing your work using substitution or elimination, and all of a sudden you get a statement like 3 equals 3, which is true all of the time. And because it's true all of the time, you get infinitely many solutions. And if I were to graph both of those lines, they'd end up being the same line. And you would have, like we talked about with graphing, an infinite number of possibilities. Not all real numbers, but infinitely many solutions. So, like normal, these will happen the majority of the time. But again, which is typical, the two that happen rarely sometimes get forgotten and people think something weird is going on. So let's talk about substitution first. We like to call things what they are here in mathematics land. So substitution, you are going to be substituting. Weird. You want to pick the method that works the best, meaning what's easiest. So if you have a variable alone, so ideally something like y equals mx plus b, but sometimes you have x equals something. It doesn't really matter. As long as one of the variables is alone, you can replace x with whatever it equals because that's its substitute. Here I could replace y with whatever mx plus b is because that's its substitute. What we are always trying to do is we're trying to get one equation with one variable. We can't solve for two variables at one time. It doesn't make any, we just can't do it. So we're going to try to find a way to do get one equation with one variable so we can solve it. I'm feeling more festive than green, so we're going for blue. So in general, what we're going to do is substitute, like I said, an expression. So here is the one that's alone, y equals, and I'm going to be doing y equals 4x minus 1. And what I need to do then is substitute it in for the y in the other equation. So the other equation reads 2x plus 3, and then it's normally times y equals 25. But right now, I'm looking to plug in or substitute something in for the y. And that something is 4x minus 1. And now I've accomplished my goal. I have one equation with one variable. So I'm going to do some mathy math, do a little distributing, a little bit of combining like terms, a little bit of adding that 3 over to the other side, a little division. So when I'm done, I know that x is 2. That's pretty exciting. Keeping in mind, however, I don't need to know just x. I'm looking for an x-y coordinate pair because I'm doing all this instead of graphing, but I am looking for the point where they would cross. At this time, I know I'm going to get a solution because neither one of these things happened up here. I didn't get a false statement without any x's, and I didn't get a true statement without x's. I got an x. So I'm going to go back and I'm going to plug that 2 in to find my y. The easiest place to plug that in is going to be right here because it straight up says y will equal 4 times whatever your x value is minus 1. So that's going to put me at 7. So if I had graphed these two, which would have kind of been a hassle, this one I would have had to graph with intercepts and they wouldn't have shown up very neatly. But instead I use substitution and I'm getting my 2, 7. If I graphed them, that's where they would have crossed. All right, so that's substitution, and I believe this is reviewed to some degree, so just kind of getting it fresh in your mind again. Shockingly, the elimination method requires us to eliminate a variable. And so we're going to eliminate a variable because our goal is to get an equal but opposite pair. And it doesn't matter if you want to eliminate the x's or the y's, so go for the easiest thing. You only have one tool in your toolbox to get them ready to eliminate, and your tool is multiplication. So if I'm looking at this, I look at my two sets of variables, 7 and 8 or 3 and 6. Since my only tool is multiplication that I can use to get them to be the same, I'm going to go ahead and pick 3 and 6 because I can make them equal one another much easier. But I also need them to be opposites. So what I'm going to do is multiply the entire top equation by -2. You can do whatever you want in terms of multiplication. You just have to remember to do it to everything. Most people remember to distribute here and here, but this guy gets left out again. And so make sure that you don't leave that as a 10. That's probably the most common mistake. So this top, and I'm just distributing that -2 carefully because the -2 times the -7 is going to turn into a plus 14y. And then I get a -20 over here. Don't leave that as a 10, please. Bottom row, I'm going to keep just as is. Sometimes I have to multiply them both by something to get them to match up, but in this case I don't, because now I have an equal but opposite pair of x's and they cancel out or eliminate. That's the name. So now I'm going to combine my y's. 14 minus 8y leaves me with 6y. A -20 and a positive 8 leaves me with -12. So in this case, I just happen to find the y value first. So make sure you put it into the y spot of your coordinates. Sometimes people think, oh, I got it first, so they accidentally put it here, which is your x position. Now you have to go back and plug in -2. It makes no difference which one you're going to plug that into. So let's just say that I took this top equation, 3x minus 7, where there used to be a y. I'm putting in my -2. And now I'm going to find my x value. Be careful right there with those negatives disappearing on you. Then I'm going to take away that 14 to the other side. And so then my x is actually going to be -4/3. So that would have been a tricky one to determine on a graph. And so that's why some of these other methods are kind of helpful. That if I had graphed it, I probably wouldn't have been able to eyeball it and say, oh yeah, that's crossing at -4/3, -2. I would have had to look really carefully. All right, so the ice cream parlor. Here we go again. The ice cream parlor gave me a lot of stress trying to graph that the other day. So we're going to look back at the exact same problem and see what method might be smarter to use. So my favorite ice cream parlor still sells sundaes that I'm still going to let be X for $4. And they still sell my malts, which are Y, for $5. And they still sold 8 more sundaes than malts. So I have the same equations. I have 4x plus 5y is going to equal my total. That's my money equation. And then the other relationship is that they sold 8 more sundaes than malts. So to get my sundaes, I'm going to take my malts and I'm going to add 8. So looking at this, you want to decide, is graphing easiest? Heck no. Is substitution or elimination easiest? Well, elimination tends to be easy when they're both in standard form. This one I would do by substitution because I already know that x can be replaced with y plus 8. So I'm going to go ahead up here and do exactly that. I'm going to replace the x with y plus 8. So in this case, I'll be solving for y first, keeping in mind that x is my sundaes and y is my malts. So distributing 4y plus 32 plus 5y. So I'm just kind of mathing here for a little bit. Now, if you remember from the other day, we got, I think it was 20 and 12 or something fun like that. Whatever we got, we still need to get, because we're going to be just using a different method to find the same thing. So when I combine these, I get my 9, taking away my 32. And then when I'm going to divide that by 9, I'm going to find out that y is 12. That is going to be 12 mults, which is not shocking to me because it was 12 mults the other day when I did the graph. Then I can come back and say, well, now I need to find x. This is the easiest place to do that because x equals the y that I just got plus 8, which puts me at 20 Sundays, which is also what I got on my graph. But here it's a lot more efficient. And more importantly, it's more accurate because like I already knew the answer when I did the graph, and that's how I made my graph look like it crossed there. But it's really easy to get off by a little bit on the graph and not be as confident about your answer. Point being, you can solve any system of equations any of the ways. So you always want to pick the most efficient way unless your teacher's mean and forces you to do it a certain way on the test. So if we take a look at a couple of examples, and if you know what you're doing at this point, you know, you can kind of ditch the video. But if you want to see a couple more examples before you hit the IXL, stick with me. So in this first example, I would go ahead and use substitution because I already know that y can be replaced with this. I also feel like I already did these examples. So not sure why they're showing up. Hopefully they're not in your packet twice. Wow, this one looks like a doozy. So when I take a look at this problem, it's in standard form. So I am going to leave it in standard form, not try to do substitution because it was really, really tricky to get one of the x's or y's alone. And what I'm going to do, there's not a great way to do either of these, but I'm looking at this, I guess, and I'm going to turn both of these into 28. So I can use elimination. In order to make that a 28, I'm going to need to multiply the top by a 7. And they're already opposites. The top is a positive and the bottom is a negative. So I just need to multiply the bottom by a 2. So distributing that 7 to everything, I'll have 28x. Then this will turn into a minus 70y. Equals 56. Don't forget that guy on the end. That always gets forgotten. Here I'm going to distribute my 2. So there's my pair that's going to eliminate right there. Here I'm going to get 70. Okay, this is getting weird. And then here I'm going to get negative 56. Okay, weirder. But this eliminates, leaving me with nothing. This eliminates, leaving me with nothing. So now you feel like you did it wrong, but you didn't. If you look back here a million pages ago, 3 hours ago, these things still exist. So I did my work and I got a true statement. It is always true. Am I making you dizzy? It is always true that 0 equals 0. That is a true fact right there. So if that's true, it means that these are always true no matter what values you put in. And so there's going to be infinitely many solutions. Not sure why I put an E. So infinitely many solutions, meaning these would, if I graphed them, end up being the same line. You don't have to say so. This would actually be your answer. You show your work, you get a true statement, you are good to go. All right, so everybody's favorite part, word problem. And so in this one, the hardest part, like always, is going to be writing my equation. So what I like to do is I read the very end so I know what my variables are going to represent. It says how many of each kind of t-shirt. So I'm going to need 2 kinds of t-shirts. Oh, my dog's going to get a really loud drink right next to me. That's awesome. Short-sleeved and long-sleeved, apparently. So I'm just going to let X be long-sleeves. I guess it doesn't really matter. And Y be short sleeves. And it's the world's longest drink, apparently. Okay, so X is going to be the number of long sleeve t-shirts. I guess I should be a better teacher and I should be really specific. So this is going to be the long sleeve shirts. you know, the number of those, and this is going to be the short sleeve shirts, however many I have of those. So that's my ultimate question. So what I kind of like to do with these is be like, okay, I used up that information. So as I'm reading this, the short sleeve t-shirts cost $5 and will be sold for $8. Long sleeve costs $7 and will be sold for $12. The school store spends a total of $2,500 and sell them for a revenue of $4,200. So basically, my two equations are going to be what is my cost and what is kind of my sale price or my revenue. And I have to piece those together. So in terms of cost, when I go back, short sleeve is going to cost $5 and will be sold for $8. Keeping in mind that for whatever reason, I made those my short sleeve Ys. So when I'm talking about short sleeves, they cost $5 and they are sold for $8. Okay, how about long sleeve? Well, long sleeves cost $7 and are sold for $12. Now, the reason I'm putting an X with them is that it's each. So it's $7 per long sleeve, $5 per short sleeve. Okay, so my total for cost, if I'm reading through here, and kind of at this point, I used up this information, and so on. So now I'm looking at my total cost. And my total cost is going to be $2,500. And my total revenue is $4,200. Wowza. So now I have my equations, finally, and I'm going to have to go through there, match them up. I'm certainly not going to graph them, and I don't really want to do substitution. So I'm going to go ahead and use elimination, but I'm actually going to partner these up. It just feels easier to turn these both into 40. But they're both positive right now. So I'm going to do that by multiplying the top by 8 and the bottom by a -5. So my top row, and of course I'm running out of space here, scoot up a little bit. My top row as I distribute the 8 is going to become my 56. Then here I'll get a 40Y. And then here I'm going to get myself a big fat 20,000, which I totally did before, not in my head, so don't be impressed. In the bottom row, when I distribute that, I'll be looking at -60. Here I'm going to be looking at my -40, which was the entire point. And then when I distribute to that last number, I get a -21,000. So mission accomplished. I eliminated my Ys. So here I get a -4x, which seems weird, but here I get a -1,000. So when I divide that out, I get I get 250 and the negatives go away. So looking back, that is going to be the number of long sleeves shirts. And then when I go and find Y, which is kind of going to be a hassle, I'm going to have to go back in and say, okay, well, I guess I take the top row. 7 times 250, because that was my X, plus 5Y equals 2,500. I'm trying to find Y. So when I kind of go through here, I'm going to have 1750. 5Y equals 2,500. Gonna do some kind of magical subtraction stuff. I'll have 750 over here. Actually, yeah. And so my Y turns out to be 150. So I'm gonna be getting 150 short sleeve shirts, and I'm gonna have 250 long sleeve shirts. So that, my friends, is what they call a really long problem, which has created what we call a really long video. But now you know everything in the whole entire universe about how to solve using substitution and elimination. So you can just IXL yourself into some fun. And there are going to be some word problems, so you can look back at this and kind of try to follow this in terms of how you set yours up.